Hello. In this video, we're going to just go over kind of a review of series, so like summations from calculus. And we're going to start with the basic series tests and eventually work our way into some of the things that the College Board likes to test us on. This will probably wind up being a handful of videos. I have no idea how many. We'll find out as we go. But to start, we're just going to jump right into a series, sigma n equals 1 to infinity of 5 over n. So this one should jump out to you. This is a p-series. P-series. And your p-value in this case is equal to what? It's equal to 1. That's because it is n to the first power right here. And that is less than or equal to 1. So, therefore, it diverges. Anytime we have a p-series with a p-value less than or equal to 1, it diverges. If this was n squared, it would be bigger than 1, and then it would converge. So let's do another one. Next series, sigma n equals 1 to infinity of pi over 4 to the n. So this one, well, we know that pi is approximately 3.14. So that means that pi over 4 is going to be approximately 3.14 divided by 4. And we know that that is less than 1. The reason why I'm looking at this and figuring out if it's less than 1 or not is because this has this n up here, which means that it's geometric. So this is geometric with, I like to write absolute value of r equal to pi over 4, which is less than 1. I know that the absolute value of r is the same as r here, but I just get in that muscle memory of writing absolute value of r. And then I write therefore converges by geometric series. All right, so the first one diverges, the second one converges. Let me take a step back for a moment. I want to say that this is not a video where I'm teaching why these work or I'm teaching these series for the first time. I'm just going over them with the expectation that you've seen them and are pretty familiar with them and you're ready to just kind of roll through them. So here comes the next one, series number 3. We're going to go with sigma n equals 1 to infinity of n over, 2 n squared plus 1. So you should say, this should jump out to you and say, hey, I think we should use limit comparison test, LCT. What I'm going to do is start with some scratch work. And we're going to just write n over, I'm just going to take this inside stuff. I'm going to get rid of the pieces that don't matter. So the first thing I'm going to get rid of is the plus 1. And that takes me down to 2n squared on the bottom. And I'm just figuring out what I'm going to do LCT with. And then I'm going to go n squared, n over, I'm going to drop a 2 because that piece doesn't matter either. And what's n over n squared simplify? It simplifies to 1 over n. You could do this with the 2 down here, but I think it's easier to just look at this thing. So I am going to use LCT with the series sigma n equals 1 to infinity of this thing right here that I just did the scratch work for, 1 over n. So if I do that, I get L equals limit as n goes to infinity of absolute value. I'm going to write an over bn. It's kind of the standard notation that we use with this. So the an is the inside of the sigma for the original one, and the bn is the inside of the sigma for the new one that we figured out. And I might write here, comma, which diverges by p-series. As a reminder, anytime I have one of these that sort of like acts like a p-series, I use limit comparison test, LCT, to show what it does. So what do we get for our limit? Limit as n goes to infinity, absolute value. I am going to, actually this one, we don't need the absolute value, so we're just going to write an over bn. I'm getting a little bit of ratio test mixed up in my head there. So when I do an over bn, I get n over 2 n squared plus 1 times, I'm going to copy dot flip the bn, which was 1 over n, and write it as n over 1, because I'm dividing by 1 over n, so we copy dot flip. This is equal to the limit as n goes to infinity of, when I simplify, I get n squared in the top. In the bottom, I get 2n squared plus 1. And then that limit, well, the 1 doesn't matter, and the n squareds cancel, and I just get 1 over 2. There's also some rules from pre-calculus about dividing coefficients. Whatever you do, you're going to wind up getting 1 over 2. So from there, all we do is we say that this is not, it's not 0, and it's not infinity. And that's really all I'm looking for. You could throw a negative infinity, but I'm looking for it to be some number that is not 0 and that is not plus or minus infinity. So a half fits that. So both series do the same thing. What I mean by that is they both do this, because that is what the easier series to work with does. So therefore I say, therefore diverges by LCT. And when I say diverges, I mean this original one right here. Cool. Let's do the next one. Let's go with sigma n equals 1 to infinity of 10 over 3. I'm going to write this as the square root of n cubed. So you should say to yourself, hopefully, it looks like a p-series, but I got to rewrite it. So sigma n equals 1 to infinity. I'm going to write the 10/3 in the top, and I'm going to write the n with a fractional exponent. So the square root becomes the denominator, the 2, and the cubed stays in the top. So I got 3 halves. So this is a p-series with a p-value of this right here. So p is equal to 3 halves. And unlike the p-series that we've dealt with so far, this is bigger than 1. And therefore, it converges by p-series. All right, let's do it. Hopefully that one's good. Let's do another one. We're just rolling through here. Let's do sigma n equals 1 to infinity of fraction bar. I'm going to say 10, I'll put it in the middle, 10n over square root of n cubed plus 1. So this one, I'm not going to fully solve it out. Instead, what I'm going to do is just say what we would do. You should see that this one is pretty similar to this other one that we did, where we used LCT because I had a polynomial on the top and in the bottom. Now I got the polynomial on the top, I got 10n, and then this thing works in the same way. So I'm going to show the scratch work. We would do LCT. My scratch is, I'm going to just drop the 10 completely because it doesn't matter. And I'm just going to write the biggest power in the top. That would be n divided by the square root of n cubed. And then I'm going to do the same thing that I did previously. I'm going to write, or in the last problem, I'm going to write n. I'm going to write that square root n cubed thing with a exponent, or yeah, with a fractional exponent. So that gives me n to the 3/2. And then I'm going to simplify, and I'm going to get 1 over n to the 0.5, which is the same as 1 over root n. And then that is what I would LCT it with. I would LCT it with sigma n equals 1 to infinity of 1 over root n. This diverges by p-series, and you're eventually going to be able to show that this thing diverges by p-series as well. And it's pretty similar work to what we did here. All right, moving on. Next series, sigma n equals 1 to infinity of 2 to the n over 4n squared minus 1. So this one is one that is like easy to forget, the easy way to do it. You might do ratio tests with this, and it works. You would get a ratio of 2, and you would say that it diverges. I'm not going to show that work because there's a much faster way to do it, and I want you to get better at recognizing when the faster way to do this is, or when we can use the faster way, and then doing it correctly. So hopefully you know what I'm alluding to. This one, we're going to use nth term. What I'm going to do is say the limit as n goes to infinity. And then I'm just going to write it without the sigma. 2 to the n over 4n squared minus 1. Well, what I want you to see is that I've got a polynomial in the bottom, and then I've got exponential in the top. We know an exponential beats a polynomial, so these terms themselves actually go to an infinitely large value, which means that we are adding them, and then we're adding things that eventually go up to infinity. So I write is not equal to 0, so therefore diverges by nth term. As a reminder, nth term can never tell us that something converges. It only ever tells us that something diverges or that it could converge. You always have to go to another test if you get that the limit of the terms is 0, whether it's p-series, LCT, whatever. Okay, let's do the next one. All right, sigma n equals 1 to infinity of, all right, this one looks kind of complicated, but I think you can do it. Negative 1 times, oops, not parentheses, times 3 to the n over n times 2 to the n. So look at that one for a moment. It's got a lot, oh, sorry, negative 1 to the n. My bad. Now look at that one for a moment. It does alternate. You could think alternating series, but this one's actually easier. This one it works the same as the previous one that we just talked about. What I want you to see is that we can write this as sigma n equals 1 to infinity of, how do I want to write this? I'm going to write it as 1 over n times 3 over 2 negative to the n. So notice all of these things had the n as the exponent, which we can combine them into one term and then write one exponent. That's kind of a rule from algebra. And then just have the 1 over n, this piece right here, as its own little thing there. What I want you to see is that these terms, this is a polynomial. I could write it one more time. Equals 1 to infinity of negative 3 over 2 to the n all over n. This one works very similarly to the previous one where I had exponential in the top, polynomial in the bottom. I got exponential in the top and linear growth in the bottom. The limit as n goes to infinity of negative 3 over 2 to the n over n, it is just not equal to 0. It alternates positive, negative, but the key is that it's not equal to 0. This one diverges by nth term. And I will see you in the next video. We're just going to keep rolling through this.